the direction of the curve. So when you're graphing logarithms, you start by graphing that parent function. The parent function here is going to be y equals the log base 1/2 of x. To these points that we pick out here, we're going to shift them what directions?
Up to
Right 2 down 4.
Right 2 down 4, good. So the properties that you have to worry about with logarithms is that you've got log base b of b is 1, and log base b of 1 is 0. Those are the two ordered pairs you're always going to work with to set up the graphs. So I'm going to pick log base 1/2 of 1/2 to equal 1. There's my first ordered pair. And then the other one I'm going to do is log base 1/2 of 1 to be 0. There's my second ordered pair. Yes, sir?
Wouldn't the second one though, without significance of x, always be 1, 0?
That's the whole point. Quite literally.
Sometimes you're funny.
It's not even like April yet, man. Just wait. It gets better. Yes, ma'am. It's a problem from the thing. It's 21. Everybody only needs to do 2 points except for Bella. Bella has to do logarithms in her head from now on. So these are your parent function. Your shifted function means I'm going to add 2, subtract 4, so I'll have 2.5, -3, 3, and -4. And I would plot those and connect them through. Okay? Yes, ma'am?
Is any type of graphing going to be non-calculated?
Non-calculator? Yes.
And there's a vertical asymptote. Wait, yeah, there's no horizontal.
Logarithms have vertical asymptotes at the k value. The exponential graphs had the horizontal asymptotes at h. Okay? Mr. Pope. Yes, sir.
So wait, at k, so -4, that would be at -4 is this.
Yes, and then your domain is going to be all values greater than -4. Your range would be all real.
H. So it'd be 2,
It'd
wouldn't
be,
it?
Yeah, I thought I had a vertical aspect.
yeah, it's vertical.
Oh, did I say it? I'm sorry.
Oh, you goofy, come on.
Come on!
Yeah, come on, Murph dog. What are you doing?
So his age is... Alright, I was just kidding. His age.
Sorry.
No, you're
Okay,
Sorry.
so
I had my exponential and my logs mixed up. It never happens.
okay. Anyways, with domain and range, then domain's just the asymptote, right?
It's because the curve's going to be going to the right of the asymptote always, so it's going to be everything greater than whatever your asymptote is, and then your range will always be all real for logarithms.
Okay, so it's just always going to be that.
Yeah.
So wait, are we going to know domain and range for the broken stuff?
We've done that before. Yeah,
How do you do that?
it's just the opposite of logs.
Okay.
What do you guys got?
So to clarify, H is
Your vertical asymptote.
and your domain. And your domain.
And your domain can be x is greater than h. Range is all real. Okay.
Wait, so for range, like you literally just write all real.
Yep, for logs. Exponential graphs. And I've got those to give back to you guys and finally talk a little bit about them now that I have everybody finally done with these things. So, okay. What else do you want to look at on here?
Number 17.
17?
So I'm just entertaining myself. Sorry.
So this one here, you got to work yourself backwards. Subtract 5.1. And now you have to get that exponent to drop. In order to get that exponent to drop, we have to take the log base 10 of both sides, or just hit the button that says log. So you take the log of both sides, you're going to get this minus 7 is the log of 43.9. That's some crummy number. To that, you add 7. Sir,
On the quiz, will it be okay to do that, or do you want to?
read the instructions.
What quiz? Wait, is this a quiz or a test? It's a test. Oh, Brendan doesn't know.
Oh yeah, this is a quiz. I was just so nice.
Hey, Joe. She didn't have one. Oh, okay.
Can we do the natural log practice? Or at least, like, if you're gonna do one of them, can we do 24?
You have to condense first. You cannot E both sides until you only have one natural log. So when you're adding natural logs together, what are you doing to whatever you're taking natural logs of? Multiply. So this is the natural log of 30x equals 3. Now to undo natural log, remember natural log is log base E, so you have to
Raise it to E.
No.
you E it.
You E it.
Just eat it. Eat it. Just eat it. So there's your answer. E to the third divided by 30.
So that's another one where you can put it to a decimal.
Yes. It'll say round it out. Okay. There's E in it.
No.
11. Like, I know you did this one yesterday, but I know you had to wait to do that add back something.
Wait, which one?
11. One more time on this one. If you notice in the middle of what you're taking the log base 3 of, it's W times the square root of two things multiplied together. So you're going to have multiple logs when you're done. Log 3 of W plus log base 3 of the square root of UV. Square root as an exponent is what? 1/2. So I'm just going to rewrite this right off the bat as UV to the 1/2.
So you can transfer exponents when it's multiplying?
Yeah. Because they're both underneath the radical. Excuse me. So now I bring this exponent out front, and I have 2 logs to worry about.
Oh.
The answer in the back had it distributing the 1/2 power to both pieces. You don't have to worry about it. Yeah, don't worry about it. There's no reason. No reason. No, I wouldn't. It's just a waste of time. Yes, sir.
Wait, so why are 7 and 8 undefined but 9?
You take a log of a negative.
Oh, duh.
That's the reason why I put those on there, because you guys all will wait, because the next one you have the negative exponent, which is just means it's just reciprocal property. Okay?
Thank you.
So, these are like the easy ones, because like 3 and 4, I get the idea, but I don't know.
Rewrite the base. You want to always rewrite it as a smaller base. What kind
So
of
like
base can you rewrite?
3
Yeah.
for 22nd, 3 to the 3rd.
And then what's 1/81?
So it's like,
Just rewrite. Or just solve for an inverse.
Wait, I don't understand the answer.
Give me a prompt.
There was no number 3.
Look one up.
I mean, I get that concept. I get
To remind you guys of how in the world you set up growth, decay, word problems. What does growth rate? What is decay rate? Things like that. So I'm just looking at, the very first problem. World population in 2000 was approximately 6.808 billion. Annual rate of increase was 1.26%. This is just a standard growth model. So it's your initial amount, 1 plus your rate to the t. Okay? Well, your initial amount was 6.08 billion. Your rate was 1.26. This is one of the things that some of you guys messed up, just calculating percentages to decimals. You didn't move decimal points enough. Which means that your growth rate is whatever this is in the parentheses, 1.0126. That's your growth rate. Okay? What'd you have, Brendan?
I have that for
Oh.
you got it right.
After that, it said write the model. Well, you just wrote the model. And then it says in the year 2010, what would be approximate population? So, what would your value of t be if the original is at 2000?
This would be 1 plus 0.0. 0, 1, 2, 6. Do you know what that's?
Because if I move this over, it would be 1.26%.
Yeah, but then that's 1 plus.
Right. So the growth rate would be 1.0126 would be the growth rate.
But the growth rate is 1 plus.
1.016.
Alright, not bad.
Yeah, the growth rate goes to the 1 plus it, and the decay rate would be 1 minus it. Vaguely remember that now? Okay. The other thing,
I'm sorry, I was just about to ask you what the growth rate was, but you just said it, so I'm good. My fault.
the other thing that comes into play, where was this one? I think it was on the back page. On the back page, they talk about compounding interest and things like that. Okay. Did you want to charge this? You don't have to waste yours.
I'm going home.
Well, you can charge it. You sure? I need to use one of my calculators.
It's at like 2%.
On 6, you got $100,000 invested at 1.01% quarterly.
This is the very last page.
Yeah.
Oh, for the growth rate? Yeah, growth rate. I think that's all right, for that, how do you write that? You just write
1.0126.
That's it.
Now, this one is the one that's talking about it's compounding quarterly. When you are compounding interest, that means you have to worry about one of your formulas. Compounded interest is your principal, 1 plus your rate divided by the number of times it compounds to the n times t, where t is generally in years. Okay? What some of you guys messed up on the quiz with this, you might have forgotten the n value. On that part, you just did that, but you raised the nt. So little simple parts. Fill in the blanks then. 100,000. 1 plus your rate. Quarterly means how many times a year? 4. And then I think it says for 10 years, and then another one for 25 years. Part B. No, I was just saying the other one just you exchange 25 and 10. Now, one of the things that I had noticed on the quiz, get these things back to you guys as you guys are working, is that you guys accidentally, I think it asked you how much would you have to initially invest to get a certain amount at the end, and that's where you guys mixed up your values. When you have a problem where you have to find initial investment, that's when you're solving for P. instead of coming out the other way. So let me see here. Let me get this one out, and we'll walk through it. And I apologize. I was going to do this during flex, but I had too many people. So start working on that. We'll do some more from this quiz. Was the one that most people tended to find a simple mistake here. It was number 3. Number 3 is asking how much money should be deposited now in an account paying 8% compounding quarterly to have a balance of $1,000 after 10 years. You want your amount to equal $1,000 after you put in some amount of principal at 1 plus your rate of 0.08 over 4, which is the 4 times 10. So what you're doing here is you're solving, basically works out to be a one-step equation. You put all this junk in your calculator here, hit enter, and you take 1,000 divided by that answer, and there's your value.
Did somebody already ask about the compound continuously?
I just asked if they're
Oh, well, can you like?
I will talk about that in a second. Okay. So, yeah, that'll mess you up.
I got $1.
I can't.
Yeah, and I think there's been a couple of people that had,
$1.
I had like, yeah, didn't I write something for you saying, hey, so I'll give you $1 tomorrow, and
You give me 1,000 in 10 years?
yes. Did you want $1? If we write a contract, I'll give you, and then
Mine was better though.
what did I say for yours? I forget.
$9.
$9, yeah, so I had to give her $9, but it's still in 10 years, she's gonna give me $1,000. So I will be more than happy to give you $1 right now, and I'll give you $9 right now, because I think I actually have $10 in my pocket, which is weird. And if you wanna write up a quick contract that you'll give me $1,000 in 10 years, I'll take it. No?
I could take $9 and make it $1,000.
You're getting $1.
Illegally.
I like it.
Okay.
9 months. Wait, I feel possible.
Pert.
Actually, $1.02.
I can get a McChicken with that.
What is it?
He was so excited about his McChicken. I was gonna get a McChicken.
What number is it?
I don't know, I'm just making it up. Anyway, Pert. If you have an account that pays 3% annual interest compounding continuously, all that is $2,500 E 0.03 per amount of time, and then it just says after 14.
What number is this?
That's all it was.
Number 10.
Pert. Yes, sir.
Hey, for number 3, how do you fist drop?
It's on the white piece of paper. It's supposed to say the first drops below 15 amps.
Oh, on the.
What is it?
No, what are you talking about, man? Hey,
You're playing paper, rock, scissors, and you're gonna lose.
Paper, rock, scissors.
Actually, I brought a gun to a rock, paper, scissors, so it wouldn't be so funny.
Yeah!
I win.
Same
thing.
2 out of 3.
He said fist, rock, scissors.
JC, would you do me a favor?
Yeah.
Can you hit him?
Am I gonna get in trouble for this? No.
Do it.
Anyway. No. JC, you had a question about something.
Oh, I was just going to ask if like number 5 and 6, the simplifying the expressions on.
Yeah, if you have the simplifying ones like 5 and 6, and what happens here with 5, you have e to the x times 6e to the 3x minus 1. In this case here, you're multiplying. Take care of the coefficients. 1 times 6, 6. E to the x, e to the 3x minus 1. They have the same base, different exponents. Just add the exponents. X plus 3x minus 1 is e to the 4x minus 1. Okay. Yes, sir.
Number 7, 8, 9. How do you check if it's growth or decay?
with the E values, you're just looking at your rate. This would be your rate. Positive, negative, that's it. Yes. Which one?
Wait, so did you finish number 15?
No, I don't think I did it right. When I typed it in, it's not this number.
In this one here, it's really simple to take care of the cube root of 125. It's 5. But then what I'm going to do is change this as e to the 12x to the 1/3. And now I do my power rule. 12 times 1/3 is,
Yay.
or if you remember how we did it with the exponents earlier, if you remember how we did it before, you go 3 goes into 12 how many times? 4 come out and none stay in. That's the other way to do it. Okay, is that what you're going to say?
Yeah, does that work?
It works the same. Yep, works the same.
All of them like
Yep.
that? Even,
So like 12 divided by
even if, like, when you do it, sometimes you know how there's a leftover, instead, that still works, you get to count it out like that.
Yep, yep, yep.
How much is close to
You guys are all freaking out about this problem where it says at what time does it get close to $0. So if you're looking at your table there, which most of you guys are doing, it's declining in price value, then all of a sudden it's worth less than a penny, right? At some point in time, it's less than 0.01. Once it gets past 0.01, isn't it kind of worthless?
Just add the
What's
minus.
one right on? Number 5.
It's very back. So if you just throw that in the table and you're looking at it, because we talked about this before, if you have depreciation, depreciation's eventually going to
Then get this.
Then we log.
bottom out at some value.
Is it really ever going to be worth that much? Even at scrap, it's always
And that's the whole idea. A lot of times you're talking about is depreciation value. It's not going to continuously depreciate. At some point in time, it's going to level itself out and be worth something. Okay. There's always going to be some value to something to somebody. You might value this stack of papers if you needed to start a fire. Whereas Mariah could care less and not value the paper at all because she has flint and dried leaves.
We shouldn't burn Flint. He's a nice guy.
What do you guys have?
when it levels out like that, is that the asymptote? Is that?
Yeah.
So if you have something depreciating, would that mean that 0 is your horizontal asymptote? Because let's say you have a piece of scrap metal, or a car I should say, and then depreciates over 100 years and now you're just left with a hunk of metal, but it's still worth something, right?
Correct. Because you think about a depreciation model, that's what that looks like. Then think about it in terms of exponential growth, exponential K. That's your A, B to the X. Oops, sorry, this was. How do we write that out? It's A. But there was no K value to any of these. So I mean, your depreciation model always levels out to 0. Where the B value was, for K, was always greater than, oops, yeah, bigger than 0, but smaller than 1. Because you're subtracting 1 minus your rate, so your rate denoted that it's going to be a decimal value there. So it's going to bottom out because there's no, your plus K, well, K is 0 because you're horizontal asymptote. And you're right, over a hunk of metal, it's still going to be worth scrap. And that's kind of the weirdness of depreciated value. At some point in time, you know, like a car, you know, just a generic car, 20 years old, it's still going to be worth something because it's made of metal. Cars later, in 20 years from now, what's that?
The equation is
Correct. It's just it's in a theoretical sense, if you will. I mean, if you think about cars nowadays have more and more wiring in them than cars 20 years ago. Wiring is copper. Copper is extremely expensive nowadays. Okay, it's the copper prices and the commodities have skyrocketed over the past few years because of the amount of technology that's needed for copper. So people that had foreclosed homes and things like that, abandoned houses were getting broken into, people were stealing their plumbing lines because they were made of copper. Because the scrap metal is worth a ton. It's serious though.
What do you do for a living?
It is
I
serious.
rob people's copper lines.
No, it was a huge problem. It's not as much as it is nowadays, but 5-6 years ago, people were stealing copper left and right. Okay, it was very, very common. Yeah, depends on the car. Depends on value. Same thing with think about home values. When you buy a house, you buy it for a certain value. It might depreciate and it might go back up. It might depreciate, it might go back up. They're more sinusoidal than they are of anything else. It's all market driven. Yes,
Can I ask you a question?
Yes.
Actually on the screen.